All right, for this lesson, we are going to discuss product of powers. This is when you have a base number that is the same as another base number and you're multiplying. And I'm going to show you how we deal with the exponents. So, if you see here, we have the products of power property. Write this definition, it's not really a definition, but the products of power property, put that in your journals, and write, to multiply powers with the same base, we're going to add their exponents. So that's the rule you need to understand. When you are multiplying powers with the same base, all you have to do is add the exponents. So they give you an example here. 4 to the power of 2 times 4 to the power of 3. So these two have the exact same base. The big number is the base, that's the 4. So when you see that, that's the same thing as saying 4 to the power of, and then you would add 2 plus 3 on the exponents. So your final answer is 4 to the power of 2 plus 3 would be 5. So this is a simplified version. Okay, now if they tell you to solve it, then you would actually do 4 to the power of 5. But if they're just having you simplify it, then this is the final answer. Okay, so again, to product of powers property, when you're multiplying powers with the same base, you add their exponents. All right, so let's practice a couple of these. All right, so let's look at example 1. Make sure you're writing this in your journals. So for letter A, we have 2 to the power of 4 times 2 to the power of 5. You see they have the same base, which is 2, so all you have to do is add the exponents, which would be 4 plus 5. Well, 4 plus 5 is 9, so your final answer, we're just simplifying, is 2 to the power of 9. Good. So for B, let's look at B. We have negative 5 times negative 5 to the power of 6. Well, that negative 5 that's at the beginning all by itself, that has an imaginary power of 1. So I would rewrite it. So you see the parentheses, negative 5 to the power of 1. It's kind of like when you have a whole number over a fraction. When you have a whole number, you can write it as a whole number over 1. This is the same idea. I can use a base that has no exponent and put it to the power of 1 just because it's there by itself. So then I have the same bases, negative 5. So then I would add the 1 exponent plus the 6 exponent to get negative 5 to the power of 7. Okay, so there's another little trick. If you have a base all by itself, you can put it as that base number to the power of 1. Just make sure if it's supposed to keep the negative or not. All right, let's look at C. Write this in your journals. We have x to the power of 3 times x to the power of 7. So in this case, they're just using a variable for their base, just a letter. But it's the same variable, it's the same letter. So in that case, you just say x to the power of 3 plus 7, which if you simplify, 3 plus 7 is 10. So your final answer is x to the power of 10. Good, let's do the on your own. All right, so grab a piece of paper. You're going to put this on your own separately. So, number 1, you see they have the same base. They are both base number 6. So we can say 6 to the power of the exponents added. So 2 plus 4. So simplify, you'd get 6 to the power of 6 as your final answer. All right, so now let's look at number 2. Again, we have the same base numbers. It's just the negative 1/2. So I can say negative 1/2. And then I have my exponents, 3 plus 6. Now remember, this only works when you're multiplying. That's the key to all of this, product. You're multiplying, so make sure you've seen that. So 3 plus 6, I can simplify that to be negative 1/2 to the power of 9. And the parentheses are important here because if I didn't have the parentheses, then it would be 1/2 to the power of 9, not negative 1/2 to the power of 9. So make sure you keep that there. All right, for this last one, we see that they've used a variable. So z, now this is a z by itself. So it's the same thing as writing z to the power of 1, okay, times z to the power of 12. Well, that's just z to the power of 1 plus 12, which would be 13. You can put a little dash in here to make these look like z's rather than my number 2's. So z to the power of 13 is the answer on that one. All right, good. Now let's do the next example. All right, for this example, this is example 2, put it in your journals. You can see that we have parentheses in here in between what we're going to be multiplying. So you got to think, this is double the exponent. So you have 3 to the power of 4, and then that whole thing to the power of 3. So remember what we did earlier when we had a number to a power? That's just itself times itself 3 times. So I would write this out. 3 to the power of 4, 3 to the power of 4, 3 to the power of 4, 3 times. Okay, once I have that, then you can add the exponents like we're used to doing. So I can say 3 to the power of 4 plus 4 plus 4. Well, 4 plus 4 plus 4 is 12, so my final answer would be 3 to the power of 12. Okay, let's do another one. We have w to the power of 5, and that whole thing to the power of 4. So that means this is w to the power of 5 4 times. 1, 2, 3, 4. Okay, and then you can add those, which would give you w to the power of, there's 4 5s, which gives you w to the power of 20. Now let me show you another trick on that. There's actually a simpler way to do that, but I wanted you to understand that concept. If I have a base number to the power of any exponent, and then that whole thing to the power of another exponent, they taught you that this just means you have 3 of these, right? 3 to the power of 4, 3 to the power of 4, 3 to the power of 4. Okay? You put this in your journals, by the way. The other way you can write that, rewrite it 3 to the power of 4 to the power of 3, is when you have a power to another power, all you have to do is multiply these. So it'd give me the base exponent of, the base of 3, and if you look here, 4 times 3 is 12. It's the same if I did it this way. I'm still going to get 3 to the power of 12. Either way, I get the same answer. So if you see a power to a power, you just think, I can multiply these two and keep the base. Okay, so let's do on your own. All right, so here's on your numbers 4 through 7. So for number 4, I'm going to show you the way they taught you to do it one more time. So we have 4 to the power of 4, and then that's to the power 3 times. That's like saying 4 to the power of 4 times 4 to the power of 4 times 4 to the power of 4. These all have the same base, so I can say 4 to the power of 1, 2, there's 3 of these, so 4 plus 4 plus 4. And that's all the same thing as 4 to the, 12. 4 to the 12th. Okay, that would have been the same thing if I had just done 4 times 3 here. I would have gotten 4 to the power of 12 again. So let's try it my way this time. So we have y as our base, and then we have an exponent to the power of another exponent. So I'm going to have y, and then I'm going to say 2 times 4. So y, 4 times 2 is 8. A lot faster. Let's look at this one. We have pi to the power of 3. Pi you just use as any other variable. And then I'm going to have 3 times 3. So pi to the power of 9. It's kind of a squished 9. Let me make it a little better. Okay. And then my last one, they're trying to trick you because there's all kinds of parentheses. But let's just break it down. We have a negative 4 to the power of 3 to the power of 2. So again, I can just say the 3 times the 2. The only catch is I leave that negative 4 in parentheses. Then I'm going to have 3 times 2. So negative 4 to the power of 3 times 2, which would be 6. Okay, don't let the parentheses scare you. Just work from the inside out. Innermost parenthesis first, then work your way out. All right, that's on your numbers 4 through 7. Let's do the next example. All right, again, on this example, I'm going to show you 2 different ways you can do that. I'm first going to show you the way the book teaches you, and then I'm going to show you another way. So in this case, you see inside the parentheses, we have, this is example 3, make sure you're writing this in your journals. We have 2 bases inside the parentheses. We have a 2 and an x, and all of that to the power of 3. Well, you can see here that can be written as whatever's in the parentheses 3 times. So 2x times 2x times 2x. What they would like you to do is to group these bases by like terms. So we have all the numbers on the left and all the variables on the right. So we have 2 times 2 times 2, and then times the x times x times x. Then you can think of those as exponents. So 2 to the power 1, 2 to the power 1, 2 to the power 1, times x to the power 1 to the power 1. And then you can add those like we've been doing. So you're going to get 2 to the power of 3 times x to the power of 3. And then the last thing you simplify, you always simplify if it has a number. So 2 to the power of 3 would be simplified to 8. Okay, let me show you B, and then I'm going to show you how to do both of these easier. So make sure you've written this down. Okay, let's look at B. So again, we have 2 bases on the inside, and we're rewriting them xy times xy because it's whatever's on the inside times itself. Then we regroup them. So we have x times x, which is just x to the power of 2, y times y, which is just y to the power of 2. And then you would simplify. X to the power of 2, y to the power of 2. Since these are both different variables, you don't have to do anything else to that. Now, let me show you a little bit easier way to do that. This, I want you to understand this concept the way they showed it to you here, but there's a faster way to do it. So keep going on your same example in your journal so you can make sure you have it. This is example 3, just in case. So A, they gave you 2x to the power of 3. Now, what I want you to remember is when you see the parentheses, that means this exponent is affecting both items inside the parentheses. So I can look at that and go, okay, well that means this is 2 to the power of 3 and x to the power of 3. Well, if you look right there, I just skipped 2 steps. I've already separated my bases, and I've put them to the exponent that they want me to. Because then all I have to do is simplify. When you simplify, you're just simplifying the number or the coefficient in front. Well, 2 times 2 times 2, which is what 2 to the power of 3 is 8. And then you just write the variable next to it. 8 to the power of 3. I'm sorry, 8x to the power of 3. Okay, so that was A. Now let me show you what B looks like. B was x, y, all to the power of 2, right? Well, again, remember anything in the parentheses impacted by this exponent. So I would just say this to the power of 2, this to the power of 2. So I would rewrite that as x squared, y squared. Hey, look at that. I'm done with that one. All in one step. A whole lot faster. Okay, so key here, remember, if you have 2 bases inside the parentheses, you have to remember that the exponent affects both of the bases. If you have 3 bases, it affects everything inside the parentheses. All right, let's do the next on your own. All right, so no offense to the book, but I like my way better, so we're just going to do it that way. If you like the way the book does it better, you may do it that way as well. Both are correct. All right, so number 8, I'm looking at this 4 impacting both the 5 and the y. So I could write that as 5 to the power of 4, y to the power of 4. Then I simplify this front part, which is 5 times 5 times 5 times 5, because it's 5 times itself 4 times. On your calculator, you can just do 5 to the power of 4. Well, 5 to the power of 4 will get you 625, and then I cannot simplify the y to the power of 4 anymore, so that is my answer. 625 y to the power of 4. So now let's look at number 9. Again, we have this exponent out here on the outside impacting both the 0.5 and the n. So that's like saying 0.5 to the power of 2 and then n to the power of 2. I put this in parentheses just because it looks easier to read. It's not required, but it is easier to look at for some reason. So then I would do the math. I would say on my calculator 0.5 times 0.5, which would give you 0.25. And then the n I can't simplify any further, so it's just n to the power of 2. All right, right, number 10, the last one. Again, this 5 is impacting both of these. So I have a to the power 5 and then b to the power 5. And since they're both variables, no more simplification needed. Done. Good. All right, moving on. All right, so we're looking at example 4. A gigabyte of a computer storage space is 2 to the power of 30 bytes. The details of a computer are shown. How many bytes of total storage space does the computer have? So you see that it has the free space is 16 gigabytes. The total space is 64 gigabytes. Then they give you 4 options here. So we know that the computer has how much total gigabytes? 64. Notice we could write 64 as 2 to the power of 6. Okay? Because if you did 2 times 2 times 2 6 times, that's what's going to give you 64. So we're going to use a model to solve this, and we're going to multiply the number of bytes in a gigabyte times the number of gigabytes total. So 2 to the power of 30 times 2 to the power of 6. Remember, we can just add those exponents, and you're going to get 2 to the power of 36. So we know that this computer has a total of 2 to the power of 36 bytes of total storage space. The correct answer, if you look at our options, is B. Now, real quick before I go on, some of you saw me, I kind of glossed over that 64, switching that into the 2 to the power of 6. Okay, they don't really explain that. This 64. The reason we switched that is because you need to get something that has the same base as what we're working with. And you see that the base we were working with was 2 to the power of 30. So we know we're going to have to multiply it to another base 2. We just have to figure out 2 to the power of what. So that's basically like saying 2 to the power of x, we know equals 64. So on my calculator, I'm just going to go 2 times 2 times, you can practice trial and error. So I could say, well, 2 to the power of 4 gives me 16. That's not it. 2 to the power of 5 is 32. That's not it. 2 to the power of 6 gives you that 64. So that's how you figure out what number you're going to put over here for 2 to the power of 6 when you get one of these in your homework. All right, let's do the last on your own. Yes, 2 to the... Okay, the last question is, how many bytes of free storage does your computer have? Well, if you remember what it said on the back page, well, I don't know if you remember, you could look in your journals. Look in your textbooks, but the free storage, or free space, I'm sorry, was 16 gigabytes. So again, we're going to use our model and we're trying to find how many bytes. So we can say that originally, remember it told us it was 2 to the, was it 30? Let me go check. Times, and we need to change this to 2 to the power of something. Well, 2 times itself, how many times, gives you 16. Well, you can trial and error it, but just remember 2 to the power of 4 is what gives you 16. But you can test it out if you don't remember that off the top of your head. You can go 2 to the power of 2, 2 to the power of 3, 2 to the power of 4 until you find that 16, however you want to do it. Once you have that, we can simplify 2 to the power of 34. So 2 to the power, and then we need to label this bytes. 2 to the power of 34 bytes. Okay, so on your number 11. Okay, so you need to do you've already done OYO, numbers 1 through 11. Now you need to do the practice and problem solving, numbers 3 through 22, and then also 25 through 27. And that's it.